Hi everyone. So today we're finally going to calculate the area of a triangle in the hyperbolic plane um, in terms of its interior angles. And today's lecture is going to be kind of short because I want you to spend some time with this on your own and see if you can solve it yourself. I would say, given the tools that we have now, it's not harder and potentially easier actually than how we calculated the area of a triangle on the sphere. So let me set it up for you um, and then I'll let you go to it. I encourage you to spend about an hour at least trying to figure it out as if we were doing this in class. So let's start with a triangle in hyperbolic space. I'm not going to need the upper half plane model for this exercise, so I'm just going to draw the triangle as it looks kind of within hyperbolic space. And we've got some interior angles, alpha, beta, gamma. We'll see from a group presentation soon that the sum of these angles has to be less than pi. And let's call this triangle T. And we're assuming it lives in the hyperbolic plane, which means we're allowed to use all the things we know about the hyperbolic plane. And let's assume that the radius of this hyperbolic plane is rho. Then what do we know? So from previous lectures, we know that the area of any ideal triangle is, I think we denoted this I rho, and it's equal to pi rho squared. And we also know that the area of a 2/3 ideal triangle with exterior angle given by alpha, well, I shouldn't use alpha because I already used it, so let's say given by phi is, I think we called this a rho of phi, and it is equal to phi over pi times the area of an ideal triangle, so times I rho. And what I claim is that with these two facts, we should be able to, using some geometry, figure out the area of actually an actual triangle with 3 vertices. And I'm going to let you just play with this for a while. So if you want no hints, then stop the video now and start working on it on your own. Okay, so if you did not stop the video, that means you would like a little hint. I'm going to give not a huge hint, but a small hint. So I'm going to color these edges to distinguish them. And my hint is, let's extend the edges, kind of like we did on the triangle on the sphere. We extended the edges of the triangle, which let us kind of compare things to loons. In this case, we want to compare things to what we know, which is ideal triangles and 2/3 ideal triangles. And my hint is, don't extend all the edges that you can. Just extend each of these edges in a single direction. Okay. So if I was going to extend further, for instance, this purple one would go off like this. The blue one would go off like this. And the red one would go off like this, right? But my hint is that's going to be too much. This is the picture to look at. So stare at this picture, see if you can see any 2/3 ideal triangles or any ideal triangles within it, and see if you can use what we know to solve the problem. Good luck.